Hello, welcome. Can you hear me okay? Welcome to the session East-West is the new North-South for networks. My name is Ricardo Quintana, and I'm a network solution architect with HPE Services. So for the lawyers out there, this is our forward-looking statement. I will leave this for some seconds in case you need to read it. Okay, this is our agenda for the session. I will start with a brief introduction. Then we will talk about data center networking traffic, and we'll delve into microsegmentation in the data center and how this fits into the next generation connectivity strategy that we see for our customers. And finally, how HPE Services helps customers with their networks. So to set the scene, let's look at the HPE strategy and the industry megatrends. This is something we usually see where we have the edge and the cloud interconnected with a network in the middle. Of course, the edge is where we gather all our data. It can be our where we have our end users, our offices. It could be our factory floor. Basically, it's the source of all our data and where we also consume data. And on the cloud side of things is where we have the computing muscle to crunch all the numbers, all that data, and whether it's with traditional applications or AI applications, we can extract business value from this data. What we want to achieve here is to secure the network end-to-end, so through the whole data lifecycle, not just the siloed networks that are present at the edge or on the cloud, but through the whole lifecycle or transit of the data. And of course, we always aim to help customers do this in a sustainable and efficient manner. So jumping into data center networking traffic, we see the traditional security approach, which is based on securing the perimeter, or this north-south external traffic, which is usually accomplished by setting up a perimeter firewall. Of course, we also have the east-to-west traffic, or the internal server-to-server inside our data center connectivity. In these traditional models, the east-west traffic is implicitly or was implicitly trusted by default. However, in the past 5-10 years, with the advent of virtualization platforms and the use of microservices, the east-west traffic within the data center amounts to 80% or even more of the total traffic within our data center. So some of the security measures we've tried to put in place in this traditional security model to try to secure this traffic is network segmentation, where we use subnets and VLANs to separate traffic. We also use network slicing. So for example, when we have a spine and leaf architecture like the one we see here in the diagram, we use EVPN VXLAN to scale the network, and also some security features like applying access lists or internal firewalls. However, all these measures are not good enough to deal with all the challenges in modern IT ecosystems. So basically, the legacy networks just don't cut it anymore, and we need a better protection for our data center and our, let's say, our data assets. So this is where microsegmentation comes in. Microsegmentation is a technique that allows us to split the network into definable zones, and this way we can dictate how data and applications interact with each other. It also allows us to isolate those workloads to limit the effect of malicious lateral movement within the networks and the data center. And of course, this helps us reduce the attack surface on our network, improve breach containment, and simplify the policy management. Now, let's look at the different ways we can, or the different models that we can follow to achieve microsegmentation. So as I said, as I mentioned before, we've been using virtualization platforms for quite a long time. So one of the first methods that that the industry started using to achieve microsegmentation is to do the microsegmentation at the hypervisor level. So the hypervisor offers networking to all the virtual machines, and it is at this level where traffic is inspected and controlled. Of course, one of the most popular examples of this model is NSX. We also have different software-defined solutions that are also embedded into different other hypervisor offerings. So one of the main advantages of this model is that it's tightly integrated with the virtualization platform we're using, but it's also a disadvantage because if we have workloads where we're not using virtualization, then we need to use some workarounds in order to apply the same policies. It also has the disadvantage that we need to consume a lot of our compute resources in order to achieve microsegmentation, so it has impact on our compute power. Another model we typically see for microsegmentation. Oh, sorry. Can you go back one slide? Is to use agent on the workloads themselves. So with this model, we install agents on all our workloads, and through these agents we can inspect and control the traffic that those workloads are using. Of course, this model has the advantage that it's very flexible because we could theoretically install agents on any type of workloads. So it would, we would have consistent microsegmentation whether we're using a virtualization platform, whether we're running on bare metal, or if we are using containerization. This also has the disadvantage that we use computing power from our servers to achieve microsegmentation. However, there's another model that we could use where we do microsegmentation right in the network fabric on the top of rack switch. So with the traditional approach that we've just mentioned, if we wanted to put in place security measures to control east-west traffic, we would have to use a firewall connected to our service leaf, then send all the traffic to this firewall on the service leaf, and then back to the destination inside our data center. And as you can see, this can get complicated really fast if we have many data flows inside the data center. So that's why we could leverage technologies like this HP Aruba CX10000 switch, which has an embedded DPU, and this allows us to basically configure a firewall right in the top of rack switch. So this solution requires components to manage the switches or the network fabric itself, but also to manage the policy or the security aspect that is the firewalls that we are going to be configuring in those DPUs, and that is the PSM you see there, the Policy and Services Manager. So with this model, we would redirect all the traffic from our workloads to the top of rack switch. There, the traffic would be inspected and filtered as necessary per our security policies, and then flow back to the destination. There would be no need for a firewall to inspect east-west traffic, and we could only use the firewall for our traditional perimeter security. With this model, we could secure traffic between workloads that are either on the same VLAN, on different VLANs, basically anything that is connected to these switches where we have the distributed firewall. And we could also secure workloads like we see here on the diagram, where we have an existing leaf switch or legacy leaf switch that doesn't have a DPU or firewall capability. Also, since this solution is not dependent on any hypervisor, it's hypervisor agnostic, we could have the scenario where we have different virtualization platforms like we see here. So for example, HPE VME and VMware platform connected to the same network fabric, and we would have seamless or consistent policies applied into both environments. We could also improve this scenario if we use third-party tools. So in this example, we're using Guardicore. Guardicore is an agent-based microsegmentation solution, but what they do have is a good machine learning algorithm that does application dependency mapping. So basically, with the capabilities in those HPE Aruba CX10000 switches, the DPU also allows us to have real-time IP-fixed telemetry. So we would send this telemetry to the Guardicore application. Then Guardicore would analyze all the traffic in our data center, depending on the applications we have running there, and suggest what firewall rules we would need depending on that traffic. So these firewall rules can then be pushed into the Policy and Services Manager and deployed onto the switches. Of course, we can also keep using the traditional Guardicore solution, where if we have workloads connected to switches that are not DPU enabled, we would install the traditional Guardicore agents there, and then the policies would be consistent across both the CX10000 environment and the environment that we have running without the CX10K that has agents running on it. So with this, we try to achieve what we call the fourth generation data center. And this is what we want to achieve. So the view we have for next generation connectivity, going back to the beginning, where we have the edge and the cloud, and a network connecting them both. So in this case, we have a SASE solution. All of these network components can provide telemetry and statistics. So we would gather all of this into a data lake, and then leverage this data lake with machine learning or AI solutions to detect problems or even predict problems before they happen. And then using the automation and orchestration capabilities built into our network devices and solutions, we would be able to react to any problems and configure or reconfigure those network devices or those network solutions that we have deployed. Of course, this strategy can help us secure our complete real estate, which is exactly what we're looking for. And the aim here, the strategy that we have, is to fulfill HPE's vision of a self-driving network. So what we basically want to do is prepare customers with this type of solutions to, to achieve this vision of a self-driving network. HPE services can help its customers in their networking needs on three main focus areas, which we see here. One is hybrid multi-cloud networking, where we help customers with data center, hybrid multi-cloud connectivity, data center interconnect, and also AI factory networking, which is very popular these days. Also, secure networking, where the main solutions we see are network access control and micro-segmentation and firewalls, which are required for security. And lastly, we offer services for large, complex network deployments, where we can help customers deploy their network services throughout multiple locations, and also help them manage the life cycle of those networks. So finally, if you are interested in any of these topics, I would suggest you check out these sessions and these demos. I will be with my colleague Dave on demo 410. So if you have any questions, if we can't take it right now in the side of the stage, you can visit us there at our booth in demo 410. So yeah, we've come to the end of our session. Thank you very much for your time. Please remember to leave your feedback for the session. It helps us improve for future events. Thank you very much.